Okay, then let's start with fair ontology metadata. I will be joined by Hendrik Borgert from NFDI for CAT today and Philipp Strömert from NFDI for Chem. I am from NFDI for ING and also involved with the TIP terminology service and also with ontology engineering in metadata for ING, for example. Yeah, our talk today is about fair ontology metadata and metadata standards for ontologies. And first, we would like to go into the question why we need those. Of course, one thing that we need is...
Screen. Sorry, now you're sharing the presenter mode and not the other screen. Sorry.
Okay, yeah, no problem. Then I stop again and start again. So then I will give you this screen. That's better?
Perfect.
Okay, thanks. Okay, first question or first objective that we have is that when we use terminologies for fair research data management, then of course we want these terminologies also to be fair themselves. And of course, this is depending on a couple of requirements. For example, we want terminologies to be hosted on trusted, reliable indexing services so that we can serve these terminologies on the one hand to human users and also to machines via APIs. Of course, we also, when we want to tackle interoperability, we want to use shared upper and mid-level ontologies, or we need to reuse terms from existing terminologies. And also we would like to give, for example, some information about alignments and mappings between terminologies. And of course, then what is also important, where metadata always come into play, is the reusability of terminologies. This, of course, depends on open licenses, but also, of course, documentation, which is human understandable, and we need good maintenance. For example, active communities that help to develop terminologies, and we also need version control management. And I guess for reusability, the ontology metadata play a very crucial role. And of course, they are also needed in some other use cases, for example. When we try to index ontologies in registries and lookup services, then it could be very handy if metadata would be standardized. And of course, that's what we rely on when we try to set up our curated sets of ontologies for the different domains, especially in the NFDI context for the diverse terminology services that we have, for example. Metadata, of course, also play a role when you try to evaluate whether terminologies are relevant for your own use cases, and of course, to evaluate what kind of quality these ontologies and terminologies have. Of course, the applications themselves need information from the ontologies to display their context as well. And of course, getting this information from the source code can be a very menial or also very time-consuming task. So this is getting very expensive over time if you try to search for metadata scattered over the web, for example. And of course, also metadata play a crucial role in the evaluation of the fairness of ontologies. And so what we need is, in order to promote the whole fair spectrum of semantic artifacts like ontologies, is that we need to have basic answers to questions like what, where, when, who, why, and how. For example, we might want to know basic facts about the ontology. What's its name? What's its scope? What can it be used for? Who created it? When was it created? When was it updated or last modified and stuff like that? Where can I find source code of the ontology? And where can I go to if I want to report some issue I have with the ontology, or if I want to give feedback on it, for example? Why is it useful for different applications, and on and on and on. The problems that we face is that these answers should actually be formalized and machine readable information, but they are not always. we are often faced with a problem that we have to look for metadata about ontologies, and we are facing the problem that we do not find it in the ontology source code yet in many cases. There are, of course, different examples. Some ontologies are better at this, others are not. So this is really, searching for information about ontologies. Of course, there are already a number of recommendations of what should be provided as metadata for ontologies. And we have also some formalizations for this and also different vocabularies already that can help to model the metadata of ontologies. There are, for example, in the context of Vidoko, this tool for documentation generation, some recommendations. Of course, we have also the OBO Foundry best practices. These are examples. And of course, we have ontologies like metadata for ontology description and publication ontology that also define terms and also doing this in a very good way by reusing more generic standards like Dublin Core and DCAT wherever possible, and also other vocabularies. Another aspect that might be important also is that we might have the need to make profiles for our different applications. So there is a bit of subjectivity to what could be really required in the metadata description of ontology and what is only optional. And of course, we have a lot of different means of expression to express information about an ontology. So there is also a need to have more mappings between ontology metadata, for example, on the ontology level, as you can see here, the DCT title or DC title or SDO name. There is a lot of variety there. And we find the same thing on the term level, for example, when we have label properties or any other annotation properties, which are very elaborate, for example, in the OBO context, but could be less elaborate in other contexts, for example. And for example, you see here RDFS label could be a very standard way to give an annotation for a term. But there could also be other ways to do this. For example, you might want to distinguish between preferred labels and alternative labels, for example. So at TIB, what we started is to think about recommendations for our terminology services from a very application-driven point of view. So we started this in the context of ontology indexing for our terminology services. And this resulted in a draft of recommendations, which is still a work in progress. What we try to achieve with that is to give a set of recommendations to all the ontology providers out there that can be used to expand the ontologies with a set of metadata that then can help to ingest these ontologies at different services, for example. So first and foremost, of course, we want this for our own service so that we can have a higher degree of automation in the curation process, so that we can get the metadata directly from our service, for our service from the ontologies. And of course, we want to have a set of required properties that should be present, but we also see that a lot could be recommended for reuse, for understandability of ontologies, what their scope is, and so on. And of course, there's a lot of information that could be optional and nice to have. And of course, the most important thing is a bit about the prominence and also some very basic stuff like where can I reach the ontology and stuff like that. I don't want to go into detail of all of these properties. So now I switch to the next slide, and I guess here Philip will take over.
Thank you, Susanna. I just wanted to briefly say basically the requirements we have in NFTI for Chem are overlapping with the slide we just saw earlier, most importantly, we are interested in having, and we need to have a description of the ontology, the chemical ontology, so that the bench chemist using the terminology service is able to rather quickly grasp the use case for this ontology, and if it's the right ontology to search for certain terms. Then, of course, when looking at an ontology, it is necessary to be able to distinguish what kind of dependencies this ontology has, if it has any dependencies to other like upper level or mid-level ontologies. And for the bench chemist, it's also very important to see in what projects an ontology is already used. If we remember Fix and Rex, what I said yesterday, there are from their status labeled as orphaned, so they are not really obsoleted, but I interpret this orphan status as you should not maybe use it in new projects, but rather have them for backwards compatibility. But for future projects, you should probably rather be looking into RxNO, MOP, and CHMO instead. So the status and as Susanna said, where something, where issues should be filed to ask for new terms or to request other changes or to start discussions is most important for our use case. And having said that, I'd like to give up to Henrik, who's going to tell us a little bit about the needs in terms of ontology metadata from the NFTI for CUT perspective.
Thank you, Philip. For CAT, we have a lot of problems regarding going over several ontologies and having the problem of needing to model different steps in the world of a catalyst, so from synthesis over its experimental steps to its measurements. And therefore, we often face the challenge that we need cross-domain ontologies, which currently don't really exist, or building our own cross-domain ontologies with metadata terms reused from other ontologies. However, we often see that a lot of definitions are either too generic, so it's hard to reuse them, or too specific, so that it cannot be generalized in terms of reusing it in such a cross-domain ontology. So as a small solution to this, we're currently working on a metadata framework where Catalyst researchers can basically give their metadata in a simplified form with definitions which are easier to read for them, because most of them are not too much focusing on one domain, but more of a generalist, so don't really know the specifics of any term. And yeah, so we have the challenge of mapping to different worlds and different domains in ontologies, which is quite difficult, and therefore we're currently mostly searching terms on building our own vocabulary. So yeah, with that, I would hand over to Susanna, I think.
It's me again. Next. Yeah. So when we have we have the draft at the moment, but having recommendations is one thing. As Susanna said, we would love to automate as much as possible. So we also need to think about validating recommendations and checking whether a certain metadata is present. And for that, we looked into what kind of frameworks we can use or approaches we can use for that. Of course, we've got a robot report that already checks for certain kind of metadata, where the default is rather focused on the term level. And for the ontology level, we have only title, description, and license so far. But of course, this could be added by using the ontology development kit. You could add more Sparkle checks for that. At the moment, we're in our recommendation, since we are focused on the ingestion procedure, we're focusing more on the ontology term, ontology level, and not that much on the term level, because that's getting more and more complex, of course. So one step at a time. And I've also talked to Nico and Chris from OBO regarding a shackle-based approach using LinkedML, because the ontology access kit already has this and kind of a better status. Unfortunately, the LinkedML schema that Chris Mungal authored for that is rather quite complex. I had a hard time really understanding it because it goes down, yeah, to a very basic level. And the important part of this discussion was that we would love to have something that is reusable for many different communities, and kind of thinking about profile things like you have a base profile that is kind of like the minimal required metadata, and then this base profile might be changed by a community in terms of the cardinality constraints, or in terms of which metadata predicate is preferred, like RDFS label versus SCORS-pref label, for instance. And then we've looked at the DCAT AP-based metadata quality assessment tool by the European Union, but this is not really ontology specific enough. So to focus only on semantic artifacts like ontologies or terminologies, this would have to be generalized, but that's also Shackle based. And then of course, currently what we have is application logic based approaches, and they have usually their own JSON schema or XML schema or Python schema inside. And in order to avoid having to map between those different applications, the whole idea is to, together with the whole community, especially regarding the work that's already been done by Clément Jonquette's working group around the OFAIR tool and OntoPortal, to have kind of like a similarly commonly shared standard. Next slide, please. Yeah, and how we at TIB started, so far we started by writing manual Shackle shapes, because we think Shackle at the moment is better than the Sparkle approach. And we test this with the already indexed ontologies to see if this works out using different error logging levels like error warning and info. Error only for the required properties, of course. So that in the end of the day, this is not just helping currently our internal TIB curators who are in charge of indexing new terminologies, but we would love to have in the future a feature where any person can say, I would like to request this ontology to be added to the NFTI for Chem terminology service, for instance, or to the NFTI for Ink terminology service. And in order to provide a feedback to the user saying, yeah, this one you just provided unfortunately fails here and there, we are trying this. And as I said, we looked into LinkedML, how to use LinkedML in order to formalize our recommendations, because it gives us different kind of representations of them, Shackle shapes, Sparkle queries, and so forth, and also an easy documentation at the same time. But we have to look more into this direction and probably speak more with the LinkedML developers with regard to this profile-based approach, because currently what LinkedML is not able to do out of the box, you can have you specify a slot URI, for instance, to say, okay, the term label or the ontology label should be RDFS label or DCT title. But in order to be able to handle also the old namespace DC title or schema.org name, you only can do exact mappings, but they're not actually allowed then when the Sharkle or a Sparkle or Shackle shape is produced. They only look for the slot URI and not for the ones that you provide as exact mapping. So this would have to be adjusted. And with this, I'd like to give back to Hendrik, how they approach the validation part in NFTI for CAD.
Yes, so I might have went a little bit out of the topic here, so I'm going to continue a little bit on what Philip said. We are mostly currently looking in terms of bioschema, schema, and our own vocabulary terms for finding reasonable metadata and terminologies. And yeah, we can see that also there are some problems. Regarding LinkML, we also use it, but here in a quite different way to aggregate our metadata in a first format. Just as a small comment to DCAT AP, I think DCAT-AP is not intended as a way to map ontology metadata and should only be used for larger document structures inside the internet. Yeah, otherwise I would think, say I skip this slide because the content is not perfectly suitable, and would hand over.
Okay, so that's then coming to an end. Basically, as we said, at the moment, we have ontologies that have a lot of metadata within their source code, which would be great if we can we can parse this. But then we have quite a few ontologies where we do not have the metadata we'd like to be able to display in the terminology service to our users, so the users can understand them better. So what do we do when it's not within the source code? It must be manually curated. As we said, this is a time-consuming process. Luckily, this happens already in different services, as you can see here with some examples, which is a good thing, because having multiple services means that if one service fails, maybe it's the funding stopped, or there are some server issues, so we can fall back to another service. So this is good for redundancy and resilience, and also for sustainability in the long run. But of course, since resources are limited, we should bundle our resources in a way that allows us to curate it in one system. And since we are hopefully in the future using a commonly shared metadata standard, all we have to do is to pull the content from one system and push it into another system, and we would not have to do as much mapping work between the application schemas that work with these APIs. And for this, Charlie gave a great talk. He shared it with me this year. So this goes in the direction, let's curate things together, because at the end, this will help all of us. So this is kind of what I would like to bring home with this slide, that, yeah, we are already working together with the people's participating in the space. We need to do this a little bit more, that hopefully in the end we have such a common schema standard. And with LinkML, we might have a tool also that represents this standard in different representations, so it's easier to apply them either as pedantic classes and applications, or for those who need JSON-LD, they get this automatically. But we have one source where we added this together. And having this would at the end make it easier for the ontology curators to then bring those metadata things that are curated in systems like the bioregistry or the terminology service or fairsharing.org, bring that back into the source code to be kind of the accepted canonical truth. And then in the end, we would have better ontologies. So this is our goal.